Okay, now we're going to try the second part. The second part asks you how much sheet metal would be required to make one of these buckets. In other words, figure out what the surface area is of this bucket. Well, the first problem you have is to figure out the right formula. So you can write down the formula you think might work. Well, it's not volume, it says area. So there's the formula. You're going to have to use this formula. But to do this cone stuff, you have to know something. R is radius, pi is pi. That's the formula. That's the circle. That's the circle at the bottom of the cone. But you see, this is a bucket and it's open at the top. So we don't even care about this circle. But the bottom of the bucket, we need some metal there. Otherwise the water will fall out. We need metal right there. That pi r squared is the area of the bottom of the bucket. So there we go, pi r squared. That's it. We just have to use the radius of the bottom of the bucket. And remember what you've got here. It looks like this. It's open at the top. This is closed. If this was the bucket like this, a truncated cone, that's what's going on here. That's one thing you've got to figure out. But to figure out the other thing, the outside of this cone, it's pi times the radius times this weird thing s, which is called the slant height. The slant height is the line going down the side of the cone. And in this triangle we're seeing here, it stands for the length of the hypotenuse of the triangle. So that's what you've got to figure out. You've got to figure out the hypotenuse of the big cone, and you've got to figure out the hypotenuse of the little cone, because you're going to find the surface area of the big cone and the surface area of the little cone, and you're going to try and figure it out. So you might want to stop the video and just see if you can do that. Can you figure out those hypotenuses? Just give it a try. Yeah. Well, let's say you've stopped the video and you've looked at it. I know that that's 6. I know that that's 15 from before. That's 20 up there. It's the same triangle here. I'm just going to bring it to make it a little easier. That's 20 centimeters. Well, that's it. The slant size of the small cone. Let's just see here. The slant side of the small cone. What do we use? And I should have written it down here, and I didn't, and I should. The slant height of the small cone is 6 squared plus 15 squared and square rooted. And you should say by Pythagoras. Write down by Pythagoras when you use it. And it's 16,16. That's what the hypotenuse is, 16,16. What about the big cone? Well, here it is, 20 squared, the big cone, 20 squared plus 30 squared, square rooted. There it is in your calculator. It looks like that. And I think I showed you I did it in a calculator. You can see how I did it in a calculator. I took a picture of it. Square root of 20 squared plus 30 squared, and I got this 36.06. Now I know what these two things are. Well, now that I know the slant height, I can just use the formula. But the big trick is, just like the volume, the big cone, volume of the big cone minus the volume of the small cone, we got to use the same idea anyways. You could stop the video again. I put in now a picture here, 16.16. That's the slant height of the small cone that's been taken away. Here's the slant height of the big cone, 36.6. Okay, you could just try and fill this out. There's the formula that we're using, but you need the area of the bucket at the bottom. See if you can figure that out. The area of the outside of the big cone and the area of the outside of the small cone. You just, like I said, stop the video and try it. Okay, now you say you've come back to work on it. Hey, this one is so easy. Pi r squared. There's the radius. There's the area of the bottom of the bucket. Pi times 6 times 6. What about the area of the outside of the big cone if there was a whole cone going down here? Well, pi rs. So it'd be pi times r times s, the slant height of the big cone, the hypotenuse there, that 36.06. And let's do the small cone. It would be pi times the radius of that small cone times the slant height of the small cone. Hey, you see this pi there? I can factor it out. So I could do it on a calculator. How I did it on my calculator, I factored out pi and went 10 times 36.06 minus 6 times 16.16 and put that in my calculator. That's 36 pi. I put it in my calculator, press equal, and I got 941 and a little bit of change. Let's see here. there's your answer. I put it in my calculator and I got 941.35 rounded up properly square centimeters, because that's the area of the metal that it would take to make this truncated cone of a bucket. Yeah, this bucket. Okay, so there you go. That's it.